When we look at the periodic table of elements, so much information is there for us to understand just pretty much anything about the different kinds of elements that are on our planet. Okay? These are the elements that we've found so far. Who knows, maybe there's more, maybe there's not. But if you look at this periodic table, there's a lot of different things, there's so much information there. There's a lot of different things that jump out at you. One of the first things that you'll actually notice is that there are different colors on this periodic table. Okay, we're not going to learn about all the specific colors. You actually will learn about that in grade 10. But one of the things I want to talk to you about is this difference between the lime green or the neon green and that light blue, sort of aqua blue. Okay, you can see here that there's a noticeable difference and it goes down like this, right? Do you see that? So that is one super important difference in the periodic table. What does that look like, what I just drew? It looks like a staircase. It looks like a staircase. And that's actually what it's called, ironically enough. Okay, that staircase is what separates two really big groups of elements on the periodic table. Because every one of these boxes on the table represents an element found on our planet, whether it's in the atmosphere, whether it's in a liquid form, or whether it's in solid form. Okay, and we're going to talk about the states of matter later, solid, liquid, and gas. We'll talk about that later. But this staircase separates two big groups of kinds of elements. Mainly, it separates the metals from the non-metals. Okay? Everything on the left side of the staircase, so all of this, and all of this, these are considered metals. The only one that's on the left that's considered a metal, and it's not a metal, is this guy right here, hydrogen, the first element in the periodic table. There's a reason that hydrogen is there. We're not going to talk about it just yet. Okay, we're going to wait till we learn about protons, electrons, and neutrons before we do that. But everything on the right side of the periodic table, okay, so everything over here, these are your non-metals. They're not metallic, okay? And that means that they have different behaviors and characteristics about them. The vast majority of metals are solid or liquid. Okay, and I'm actually, with the exception of this guy here, hydrogen is a gas. But everything else here that we talked about is either going to be a solid or a liquid on the metal side. And everything on the non-metal side is going to be a gas. Okay, for the most part. Another bit of information on this periodic table is how to go about reading the periodic table. And we talked about the fact that this is a grid. This table is a grid. And how we read the grid is by giving us X and Y coordinates. Okay? In periodic table speak, in the language of the periodic table, one row here, okay, this first row, number 1, has how many different elements in it? It's got 2. It's got hydrogen and helium. Okay? Forget about all that space in between. They're actually placed where they are for a reason. And we will talk about that. Okay? Periods are periodic table language for a row. So we will be referring to rows on the periodic table as periods. All right? So these are, okay, all of your periods, 1 to 7. We don't talk about lanthanides and actinides, okay? In terms of coordinates on the periodic table, we won't be talking about these guys. They're still there and they're super important, but they don't fit the grid, okay? So I'm not going to ask you to identify the location of these guys, okay? Now, the other axis that we use to read the periodic table is the y-axis. Okay, the vertical, because these periods represent the horizontal, but the vertical columns on the periodic table are known as groups. Okay, so these are groups. Now periods, so in the case of, if we looked at period 2, where we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Those are the elements found in period 2, in row 2, right here, okay? All of these. Those are all in the same row because they have similar characteristics that make them all be in the same row. Just like elements that are in the same group, in the same column, all have similar characteristics. So if I look at hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium that are all in group 1, they are all there because they all have a similar characteristic about the way that electrons line up in their actual atomic models. Okay, they all have the same behavior, which makes them react in the same way. Okay, these are actually known, with the exception of hydrogen. Hydrogen is a gas at room temperature. All the other ones are actual metals. They're solid, and they're highly reactive in nature. Okay, if you expose pure sodium to oxygen in the air, sodium will combust. It'll light on fire, it'll explode. So when people store sodium, because you can mine sodium in the ground, they actually have to submerge it completely in oil for it to not be exposed at all to oxygen. It's really cool stuff. And as soon as it comes into contact with oxygen, it starts bubbling and it starts making all kinds of little sounds, and it releases a tremendous amount of heat and energy. It's pretty cool stuff. Okay? Now, do you understand the difference between a period and a group? Yeah? Okay, moving on. Now we're going to talk about another little pattern on the periodic table. We're going to talk about the order of these actual elements, because there's a reason that hydrogen is first and helium is second and lithium is third and beryllium is fourth and gallium is 31st, okay, and I don't know, zirconium is 40th. There's a reason behind all of these spots. You'll notice on the periodic tables that you have in front of you that, and on this one, that we actually have within the periodic table, within each little box, okay, within each little box, and you'll notice at the top of your periodic table, you have a little legend or a key there, where you have one box, okay, I believe it's beryllium, and you have this box with all kinds of different information in it. So we're going to look at some patterns here, all right? Now, if you look at that box, you will see that there are two separate kinds of numbers. There's one number that's a whole number, no decimal. And that number, if I'm not mistaken, is in the top left corner for you guys. Okay, it's also in the top left corner here. So if we look at this, we see this number here, 5, 6, 7, 8. Notice how we start at 1 and we end at the bottom of the periodic table in the far corner here with the largest number, 118. Okay, and every one of the elements there is in ascending order by 1. So 1 followed by 2, followed by 3, 4, space, 5, 6, 7, 8, 9, 10, new period, 11, 12, space, 13, 14, 15, all the way to 18, new period. Do you see that? And every one of those boxes has in the top left-hand corner a whole number. And that number increases by 1. Do you see that? That number actually represents something very important. That number represents something called the atomic number. And the atomic number represents the number of protons in one atom.